Hi there and welcome. I'm Rebecca Weaver. We're going to cover Chapter 3, Section 1 today. Chapter 3 is different techniques of differentiation. Going to be some really cool tricks that we'll be able to use to take the derivative. First up, we have the product and the quotient rules. The product rule tells me that if I have a function of two functions and they're multiplied together, and I would like to take the derivative of the product of those two functions, I would write down the first function, f of x, multiply it by the derivative of the second function, plus the second function times the derivative of the first. Now, the proof for this particular rule can be done. We're not going to do it here. We're just going to show you how to do it first. So the derivative of the product of two functions is the first function times the derivative of the second, plus the second function times the derivative of the first. It'll be helpful to have that rule handy so that you can use it. So let's look at this function. Notice that I have two functions being multiplied together. My first function, I'll call f, will be x squared plus 3. My second function, I'll call g, would be the quantity x squared minus 3 all raised to the 10th. Now this means I can use the product rule and the general power rule to compute the derivative of the entire function. So what I need to do first, if I want to take the derivative of the product of these two functions, I'll write down the first one, that's x squared plus 3. I'll take the derivative of the second one, plus just write down the second function and then take the derivative of the first. So it really doesn't matter which order that you do that in. It's just take the derivative of one, leave the second one alone, plus the derivative of the other, leave the next one alone. However it is that you want to memorize that is up to you. So you're going to write down the x squared plus 3. Then you're going to take the derivative of that second function. So that's 10 times the quantity all raised to the 9th, and then you'll have to take the derivative of that inside function, which is the x squared minus 3. Plus, you're going to write down this g function, the x squared minus 3 all raised to the 10th, times the derivative of the first, which is 2x. Now that looks really complicated, I know. So you might want to pause this and really look at it one step at a time. After that, it's just simplifying after you've taken those derivatives, and these will require quite a bit of simplification. This one, you probably could write it out a little simpler than what I've done here, but we're just looking at the product rule first. So let's look at the quotient rule next. And the quotient rule is a little more complicated. In this one, you have to really be careful and remember the order of the terms in this formula because of the minus sign. In this one, you have one function over another function, so you'll have some f over g. So you'll write the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. That is the quotient rule, and believe me, it looks complicated, but the quotient rule makes your life much easier. So if you have some function, say y equals the quantity x to the 4th minus 4x squared plus 3 all over x, we can use the quotient rule. We'll let f be the numerator and g be the denominator. Then what we will need to do is we will write down our denominator times the derivative of the numerator minus write down the numerator times the derivative of the denominator all over the denominator squared. After you take those derivatives, then it's just a matter of simplifying. And if you simplify this, you end up with 3x squared minus 4 minus 3x to the negative 2. Now, you could have done this a different way. You could have just divided out that x and gotten individual terms. If so, you would have gotten x cubed minus 4x plus 3 to x to the minus 1. That's fine. You can just take the derivative of that, and you'll get the exact same thing that we got doing it the other way. So that's just to kind of confirm that you do get that same answer using the quotient rule, just since we didn't go through the proof of that. Let's look at an example Now the width of a rectangle is increasing at a rate of 3 inches per second. That's a rate, so we know that that's a derivative. And its length is increasing at the rate of 4 inches per second. That's another derivative. That's going to be L prime and W prime. At what rate is the area of the rectangle increasing when the width is 5 inches and the length is 6? So since we are looking for the rate at which the area of the rectangle is changing, we need to evaluate the derivative of an area function, a of x, for those values. And to simplify, let's just say that's happening at time 0. Time 0, okay. So we have the function a of t, area equals length, which is a function of time because it's changing, and width, which is a function of time because it's changing. If I want to know how the rate of the area is changing, I take the derivative of area. I'm going to need the product rule because I have L of t and W of t are both products. So I will incorporate that into the product rule. And since we know that the width of the rectangle is increasing at a rate of 3 inches per second, that's W prime. That's 3. Since the length is increasing at a rate of 4 inches per second, that's L prime, and that's 4. If it were decreasing, I would just use a negative number there. So just in case you get that, because sometimes that happens. Length and width change with time. They might increase, they might decrease. So we're determining the rate at which the area of the rectangle is increasing when the width is 5 and the length is 6. So here we have this formula that we computed for A prime, and we're just going to plug in the values. The value of, at that particular time, the length is 6. I'm just going to plug that in. We know how the rate is changing. The rate of the width is changing by 3, so we'll plug that in. Plus, we know the width at that time, it's 5, and then we know how the length is changing. So we'll just plot those values in, do a computation, and we get that the area is changing at that particular time at a rate of 38 inches squared per second. Another way to order the terms in the product and the quotient rules for the purpose of memorizing them more easily is the following, and this is how I usually remember it. So what I do when I have a product rule is I say take the derivative of the first, leave the second one alone, plus take the derivative of the second, leave the first one alone. For the quotient rule, you don't really have a choice. You have to memorize it just as it sits. But what I do is say take the derivative of the numerator times the denominator all by himself, minus the derivative of the denominator times the numerator all over the denominator squared. And that is section 3.1, just a few little rules to make taking the derivative easier, making it so you don't have to plug it into that limit definition, which is not a happy place. So if you have any questions, be sure and email me, rweaver10@alaska.edu, and have a wonderful day.